Let's now take a look at the UseCallback hook in React. The UseCallback hook is a hook that allows us to do performance optimization. It is similar to the UseMemo hook. In the UseMemo hook, we provide as input a function and we cache the return value of the function. In UseCallback, we provide a function as an input and we cache the reference to the function. And so to demonstrate on the differences, let's do an example. In VS Code, I've created a few custom components to demonstrate this. Let's take a look. In the components folder, I've created a counters component. In the counters component, we essentially have three state variables, counter1, counter2, and we have a state variable that captures the theme that we want to display on the UI, whether the theme is going to be dark or it's going to be a non-dark theme. As well, we have in the component inline CSS captured by JavaScript, which captures the background color and the color of the text on the basis of the theme is dark state variable. And as well, in the JSX, we essentially have two counters and we capture those based on three JSX tags. One is the header and the second is the counter label, which is a custom component that we have also created in the project. And we have a counter button. Let's take a look at each of those. Counter label is a simple child component that allows the parent component to provide through a prop the counter ID and the counter value. And in rendering the counter label, what the JSX does is it prints a message to the console that it is rendering the counter label. And as well, in the JSX, it prints a message to the user, which is the counter value is X. That is the counter label in a nutshell. The counter button is also a simple component where in the props, we are accepting the counter ID and we're accepting in the input as well in the props a function, which allows the user to increment the counter. In the JSX, we are also logging a message to the console that we are rendering the counter button. And as well in the JSX, we have a button HTML tag, which has the message increment counter. And when it is clicked, as an event handling mechanism, we invoke the function that is provided from the parent component. So that is the counter button. Now going back to the counters component, in the JSX of this component, we have the first counter section, which captures the counter 1. Similarly, we have counter 2, because as you may remember, we have two state variables, counter 1, counter 2. And in the third part of the JSX, we have the theme, which the user can toggle by clicking on a button. On click, we update the state variable, whether the theme is dark or not. Now, in the increment counter functionality for each of the buttons, we have a function that we're providing as a prop. For the first counter, we are providing update counter 1 as a prop. And if we look at update counter 1 function, we essentially are invoking the updater function for the counter 1 state variable, and we increment it by 1. And we do the same for counter 2. So that is in essence the sample code that we have created in the project. Now let's take a look in the browser. In the browser, you will see counter 1, counter 2, and the form theme section. Now let's look at the developer console in the browser. And what you will notice is when the page is first loaded, all the components are rendered, and that is displayed by the messages you see here. So let's say we were to change the theme in the page. So if I click on that, what you will notice is the components, the ones that had nothing to do with the theme, which are the two counters, are actually getting re-rendered. This is inefficient. What ideally we would want in our application is if the component doesn't have any change to its props or state, we do not want to re-render it because we know that nothing has changed in the UI. So what can we do? In React, what we can actually do is we can use the react.memo functionality. So if we go back to our counter label component, what we can do is when we do the export, we can wrap our declaration with a react.memo function. That way, we are indicating to React that this custom component should not be re-rendered in the browser if the props or the state of this component have not changed. Let's do the same update for the counter button component. We will update the export declaration. So by doing so, we are indicating the same to React, do not re-render this unless the state or the props have changed. Now, if we go back to the browser, what we will do is we will refresh the browser. We will see the components are rendered because the first time the page is loaded, they're rendered. Now, if I clear the console and change the theme, you will notice that the labels are no longer rendered. So that is an efficiency that we can get from the React.Memo capability or functionality that we get from the library. But you're probably wondering, why did the buttons get re-rendered? Let's take a look. If we look at the counters component, when we have the counter label component, in the prop we're providing a value, whereas in the counter button we're providing a function as a prop. So if we look at how JavaScript works, JavaScript checks equality between two things based on differential checks. If we have a simple data type such as a number, it's able to check that, for example, value of the number 2 is equal to the value of number 2. But if we have two objects of the same type or two functions that are the same, they're not actually the same because they're two different instances. Now, when the counters component is re-rendered, what happens is this function that we've defined to update the counters, update counter 1 or update counter 2, what we end up doing is we end up creating another instances of these. And because we are creating another instance, the instances are going to fail the referential equality check. And because they fail the referential equality check, React.Memo is not able to utilize its efficiency. It actually thinks that the function has changed, and hence it causes the counter button component to re-render. So what can we do? Well, the answer to this is the UseCallback Hook. So to use this, let's import it first from the React library, which I've done. Now to use it, what we can do is essentially we can wrap the updater functions, which are update counter 1 and update counter 2 that we defined, with a UseCallback hook. Now, as with all hooks, it is done by invoking the UseCallback function, and the UseCallback hook takes as input a function and it takes as input a dependency array. Now in the dependency array, what we have to indicate to UseCallback is when does the function itself change, or what does it depend on which would cause it to change. And in this case it would be counter 1. If counter 1 value has not changed, then we no longer need to create another instance of the function because it's going to do the same thing. So that is what UseCallback is doing. UseCallback is essentially going to cache the reference to the function and allow us to avoid creating another instance of it. Now if I were to do the same for the update counter 2, then we will see what happens in the browser. So now the update is done. Let's take a look in the browser. I'm going to clear the console, and what we will do is we will reload the page. When we reload the page, the first time everything is rendered, so the console messages are expected. I will clear the console again. And now if I were to change the theme, you will notice that nothing happened in the console. And that is because we are no longer required to update or re-render the label component, and we no longer require the button component to be rendered again. So that is the efficiency that we get from the UseCallback hook. Now you're probably wondering the difference between UseCallback and UseMemo. Now it's very important to note, because a lot of developers make this mistake. UseCallback is caching the reference to the function. It is not caching the return value of the function. UseMemo caches the return value of the function. And that is essentially the difference. Because in UseCallback, we can essentially have a function that we are just saving it from creating or getting instantiated again. And because of that difference, because UseCallback is providing a function reference, we can have parameters that we can provide to the function. So suppose in the update counter functions that we're providing as props, we wanted to provide a value that the child or the invoking component provides to increment the value by. So rather than incrementing by 1, we have a parameter that says increment by, which is going to be a number provided as a parameter to the function. Now let's make the update in the code for both of the functions. So increment by, it's going to be a number type, and as well we're going to change the update value. Now in the counter button, We can as well update the prop. So this will accept increment by, which is a number. Now what we can do is when we invoke the increment counter, we can provide a value, because UseCallback is providing the function reference as a prop to the counter button component. Now if you go to the browser and clear the console, reload the page, we will clear the console again, and we will see if we increment, we are incrementing by 2 instead of 1 now. So that is the advantage of UseCallback, because we're caching function references, and that's what we're using to do performance optimizations. So that is it in a nutshell.